Alright, here we are. We're going to try level 2 now. Level 2, we're going to look at some transformations and decide what kind they are, and then we're going to do descriptions of them, mathematical descriptions. So here's the first one. Look at the picture here. We've got A and we've got A prime. So A is the original and A prime is the image. And here's the origin, or 0, 0. So we've got to kind of look at this and figure out what's happening. So what I notice is that it can't be a reflection, because if it was a reflection, then this point would be exactly the same over here, but there's nothing over here. So it's definitely not a reflection. It's not a dilation, because these are actually the same size. It could be a translation, but if it was a translation, then it would look the same way. So it looks different. It looks like it's been rotated. And I think that's probably what it is. What I'm going to do is I'm going to find a point and its corresponding point. So if I look at this point, well, it corresponds to this point here. So the way I check it to see if it really is a rotation is I draw a little line to the origin and then another line to the corresponding point. And if you look at that, that's a 90-degree angle. If all other corresponding points make 90-degree angles, then it's a 90-degree rotation. So let's try this point and its corresponding point, this one. And you look at that, sure enough, another 90-degree angle. So it looks like what's happening is that this one has been moved 90 degrees around the origin to make an image. So that's what I'm going to go with. I'm going to name it a rotation. And my description is plus 90 degrees. The reason it's plus is because it's been moved clockwise. So it moves from here to here, which is clockwise. So that's considered plus. If it was moving from here to here, that would be counterclockwise, and it would be a negative 90-degree rotation. Okay, let's move on to number 2. So here's our image, and here's our, here's our original, and here's our image. Sorry about that, everybody. A little tired. Okay, so here is the original. And the thing about the original is that it looks exactly the same as the image. It's the same size, it's facing the same direction. So it's probably not a reflection, because if it was a reflection, it'd be facing the opposite direction. And it might be a rotation, but you notice if you rotated this point around, or this line around, it would end up right here, and it doesn't. So what seems to be the best description of this one is that it's actually been moved down and to the right. It is a translation. So the best way to deal with a translation is find one point, it doesn't matter which point, but find its corresponding point in the image. And we're going to figure out, well, how far did it move to the right? 1, 2. So moving 2 to the right means x plus 2. And how far did it move down? 1, 2, 3, 4. So moving down 4 is y minus 4. So here I'm going to name it. It's a translation. And the description is going to be x plus 2, because it moved 2 to the right, comma, y minus 4, because it moved 4 down. X plus 2, y minus 4 for the translation. One more time. It's x plus 2 because from here to here is 2 to the right. And it's y minus 4 because here is 4 down. So there you have it. Translation, x plus 2, y minus 4. Okay, on to problem 3. Problem 3, well, we've got this thing. It looks like a heart, or maybe a V if you're not feeling romantic. And then you've got the image that's right here. And it looks like the same thing, exact same thing, upside down. So it's probably not a translation, because it can't turn around if it's a translation. It might be a rotation, but if we were to rotate it over here, it would end up pointing this way. See, it's pointing this way, and when you rotate it, if you rotate it to this spot, it would be pointing this way. So it's not a rotation. It's not a dilation, because it didn't change size. What it's got to be is a reflection, a mirror image. And if you look at it, this line is the exact halfway line. So it's bounced over this line. It's reflected over this line. So first thing I'm going to do, I'm going to label it a reflection. And then I'm going to say it is a reflection over the x-axis. So I'm going to name it here. It's a reflection over the x-axis. What that means is that the line of reflection, where it's bounced over, is the x-axis. If it was over here, that would be the y-axis, but it's not. This is a reflection over the x-axis. Okay, let's look at number 4. Number 4. This time our original is this dinky little one, and our image is this bigger one. So that's kind of a giveaway. If they're two different sizes, then what you know you have is a dilation. And a dilation is about it getting bigger from the origin. So like, we're going to figure out how much bigger. So this point here is 1 from the origin. The corresponding point is 1, 2, 3 from the origin. So it seems like it's a dilation of a scale factor of 3 over 1. Just to check, let's look at this one. That's also 1 from the origin. Its corresponding point is 1, 2, 3 from the origin. So in each case, the image has a 3 to 1 scale factor over the original. So our description is going to be SF, which stands for scale factor, equals 3 over 1. And there you have it. Okay, let's move to the next one. This one I like because it can confuse you at first. It almost looks like reflection. Like if you flip that over, maybe it would look the same, but it doesn't quite, because see, this point would have to be like over here if it was a reflection, so that's not quite right. It's certainly not a translation, because this triangle and this triangle are not facing the same direction. And I don't think it's a dilation, because they seem like they're the same size. The issue is really that they're just facing different directions. So it's good to identify, say, corresponding points. So the corresponding point to this one is this one. And if you draw a line to the origin and then to the other one, you can see that the measure of this angle is 180 degrees. Also, if you check out this point and this point, they also form a 180 degree angle, or a straight line, meaning that this one has been rotated exactly 180 degrees around the origin to create the image. So the type is rotation, and the description is 180 degrees. You could say plus or minus. It doesn't actually matter, because 180 degrees, it's the same. Plus and minus are the same. Alright, next one. And this one, the original is down here. See, that's A. So A is always the original, and A prime is the image. And I look here. Here's the origin. So maybe it's a rotation. If it was a rotation and it's going to move 90 degrees, now this square would be right here if I moved it 90 degrees. See, just make a little 90 degree angle and you can see it would be right here. It's clearly not a reflection. I'm going to go with this as a translation. And that means that it hasn't been flipped over or anything. All that's happened is moved up and to the side. So it moves from here to here. And things you got to think about is you're going from here to here. So you got to figure out a description of what happened. So first of all, it's moving to the left, which is negative. It's moving 1, 2 to the left, which means x minus 2. And it's moving up 1, 2, 3, 4. Just to check, all corresponding parts should do the same thing. So like from here to here should also be x minus 2, y plus 4. Let's try it. X minus 2, 1, 2, y plus 4. 1, 2, 3, 4. Sure enough, we got it. This one is a translation. And it's going to be x minus 2, y plus 4 to describe that translation. Okay, two more. This one's a little interesting. It actually has two possible answers, I realize. This shape is the original, and this one here is the image. So you can look at it two different ways. Any guesses? Could it be a reflection? Well, if we look at this point and mirror it to the other side, well, if it's 2 to the left of the y-axis, then its mirror image needs to be 2 to the right. Well, that works. And this, if it's 1 to the left, this one would have to be 1 to the right, so that works. So the entire thing is indeed a reflection. And sure, black, black, white, white, black, black, white, white, it certainly is a reflection. But it's also something else. It's possible to conceive of this as a rotation. If you look at this point and take it to here, well, that's a 90-degree angle. And if you look at this point and take it to here, that's another 90-degree angle. If you look at this point, take it to here, that's also a 90-degree angle. And this one moving to here is also a 90-degree angle. So interestingly, this one could be a reflection or a rotation. I'm not going to say that there's a right answer. Either one is right. It's either a reflection across the y-axis, or a rotation a little bit counterclockwise, so negative 90 degrees. Either answer is fine. Reflection in the y-axis or rotation of negative 90 degrees. Alright, our last one. And these ones are kind of giveaways. Here we've got our original and we've got our image. And our original is small and our image is big. Anytime there are different sizes, it's a giveaway. You know it's a dilation. Alright, so just take one point, for instance. This point has an x value of 1. Its corresponding point has an x value of 3. This point has a y value of negative 1, and its corresponding point has a y value of negative 3. So it seems like in both cases we're multiplying by 3. This one is 1, negative 1. This is 3, negative 3. So in all three cases, all we're doing is multiplying by 3. So it's easy to see that what we have here, our description is going to be scale factor equals 3 over 1. Okay, and that's it. So that was level 2. I hope you're having a good time practicing with it. Rewind it, watch it a couple of times. Make sure to listen carefully to the details because there are some details in there. But I think if you pay close attention, you should have no trouble doing the work. Thanks.